if I want to draw S as a function of time, as we said first, in the first phase, we have a second degree parabola, and it is varying in this way. Okay, we said that to find the point here, we need to find the area under V graph, which is a triangle, and the area is 100 times 10 over 2. So this area is 100 times 10 over 2, which is equal to 500. So it is the same result we obtained in the other method. So here it is 500. And then in another step, in the second phase, what is happening now is that V is still positive. So S will still increase, but now the slope will decrease because V is decreasing. Okay, so if I want to draw the variation of slope, I have initially a slope of 100 here. So I start by a very high slope of 100, and then my slope will decrease gradually in a gradual way until reaching a slope of 0 at the final time, which is 60 seconds. So at 60 seconds, I have a slope that is horizontal. Okay, so from the variation of my slope, I can draw the concavity. I can say that in the second phase, the concavity is downward because the slope is decreasing, and the S is increasing because V is positive. So now to finish my graph, all I need is to determine the final value. So I need the final value at S. This is why I say that delta S, so the variation of S from 10 to 60, okay, is equal to the area under V curve. So if I look at the V curve, this is the area I should take. I should take the area of the second triangular part. So A2, I can write that A2 is equal to 100 times the thickness, the base is equal to 50. So 100 times 50 over 2. So it's equal to 2,500. Okay, and then I will say that delta S, so delta S between 10 seconds and 60 seconds, okay, is equal to A2, okay. So if I replace, I have delta S will be equal to S at 60. So at 60 minus S at 10 is equal to 2,500. So S at 60, yeah, just guys 1 minute to put it on the chart. So as we said, we can now deduce S at 60 seconds, okay, which is equal to 2,500 plus 500, so equals to 2,500 plus 500, which is S at 10, equals to 3,000. So here you can say that my graph will reach a final value of 3,000. So what is the total distance traveled? So the total distance traveled is 3,000 meters. Okay. Any question on this? So let us look at the solution here. You can see the graph. So as we did, you can see that first we have a parabola that is concave up, then we have a parabola that is concave down, and we end up by a value of 3,000. The graph is not, our graph is better because it's more to scale, okay? The graph is not to scale.
Doctor?
Yes?
For what you found S is 3,000. Why
Yes.
didn't you just replace the T by 60? Why did you do delta S? Never mind. ماشي خلاص.
Okay,
Thank
delta S هي variation from 10 to 60. يعني هي S at 60 minus
you.
S at 10.
Yes.
Okay?
Okay. Thank you.
Oh. Okay, another problem. The VS graph describing the motion of a motor is shown. Construct the AS graph of the motion and determine the time needed for the car to reach the position of 120 meters. Okay. So here we have v function of s, and we want to deduce the graph of acceleration. Okay. So to deduce the graph of acceleration, we should use the formula between a, v, and s. We know that ads is equal to vdv, or if we can write it in another form, a is equal to v times dv by ds. Okay. So here we can find the equation of a because we know v. So let us find a for the two phases. So here we have two phases of motion between 0 and 60 and between 60 and 120. And please guys pay attention here. It's not function of time. It's not v function of time to say if v is linear, a is constant. Okay, no, it's v function of s. So you should use this formula. So between 0 and so for s, we have two phases. We need two equations. For s between 0 and 60, what do we have? From the graph, we have that v is equal to 0.2s plus 3. 0.2s plus 3. Okay? So if I apply the formula, a is equal to the velocity function, which is 0.2s plus 3, times what? Times derivative of v with respect to s. So here, if you derive v with respect to s, it's a constant, so times 0.2. So as you can see here, a is not a constant, it's variable. Okay? Now, so it's equal to 0.04s plus 0.6. Now, for the second phase, between 60 and 120, so for s between 60 and 120, what is the expression of velocity? V is constant. So since v is constant now, you can directly say that a is 0 because dv by ds will be 0. So a is 0 during the second phase. Okay. So now we got the expression of velocity of acceleration during the two phases. Now what I want also is to determine the time needed to reach position of 120 meters. Who will tell me how we will get the time needed to reach the final position? How to calculate time here? Look, how should we think? We know
delta S equals V delta T.
Okay, we cannot say delta S equal V delta T because V is not constant. If V was constant, it's right what you are saying. But V is not a constant, so you should go back to the differential relation. Okay, I will use the relation involving S, V, and T. So I know that V equals to ds over dt. Okay, so from this relation I can get time. Why? Because I can replace v by its expression. So first, for the first phase, I will find the time of the first phase, then I will calculate the time of the second phase. So for phase 1, v equals ds by dt, and I replace v by 0.2s plus 3. Okay, so now if I do separation of variables, I can get the time for the first phase. So separating variable, I have ds over 0.2s plus 3, okay, equals to dt. And now I integrate this relation from 0 and s for s, and this relation from 0 to t. Now what is integral of 1 over 0.2s plus 3? If you, from calculus, okay, you can say
ln
that
of
it is,
0.2s
yes, it's ln of, but don't forget to divide by what?
times 0.2.
Divided by 0.2. Okay, so ln of 0.2s plus 3 over 0.2. and I apply this. I apply which boundaries? So between 0 and s, 0 and s, okay, equals from the other side to what? Equals to t minus 0, because integral of dt is t, and between 0 and t it's t. So by just now replacing s, you are interested in the final time of phase 1, okay, at 60. So what you will do, you will integrate here between 0 and 60. So you get t of phase 1, okay. Now for the second phase, if you want, as your friend said, because v is constant, okay, because v is constant in the second phase, we can use the relation your friend proposed. That is, for phase 2, I can write that delta s is equal to v delta t, okay, v delta t. So I can find the time of phase 2, then delta t2, t2 I will call it, which is the time of phase t phase 2, okay, is equal to delta s. What is delta s of the second phase? From 60 to 120, what is delta s? 120 minus 60, it's 60. So it's 60 over delta over v. V is 15. So I get that the time of phase 2 is 4 seconds. But keep in mind that this is only the time of the second phase. How to find the total time now? T total. What is T total? It's T phase 1. So the time for phase 1 plus the time for phase 2. Okay? Clear? Because we we got T phase 2 only this part. When we calculated the time of the second phase, we calculated the time from here to here. Then to find the total time, you should add these two, T1 plus T2. Okay. Now, if you have calculated T starting from the origin, and to get T starting from the origin, what you do? You say that T of phase 2, which is a delta T if you want. Okay. Delta T of phase 2 is equal to the total time T total minus T of phase 1. Okay. So you can reduce from this relation, you can say that T total will be the summation of the two times T phase 1 plus T phase 2. Okay. Any question on this? So we are done for today. Thank you.
Thank you, doctor.
Welcome. Bye bye.